Namaskaram everyone.
Good
Welcome
morning.
to the physics webinar of today. In continuation of previous lesson, motion in a straight line. Presenter of today, Mr. D.V.RAMANA Rao, PGT Physics from TSMS Elagandal, who is well known to you, who has already dealt 3 lessons in the same topic, is going to continue motion under gravity and relative velocity. Till yesterday, sir has been dealing the previous topics and concluded till the equation of motion in a straight line. I request and welcome Shri D. Venkatramana Rao Garu, PGT Physics, to continue his session. Over to you, sir.
Okay, thank you, madam. Good morning, children, all of you. I hope all of you are doing well. So in the last 3 classes, we discussed what is actually a straight line motion, that is one dimension motion, and what are the parameters required to describe the motion of a body in one dimension, and how to find velocity, acceleration, and with the help of graphs, how acceleration can be calculated, and all these topics we discussed. So let us try to review what we discussed in the last session. So we discussed uniform acceleration and non-uniform acceleration, position time graph for accelerated motion, velocity time graph for accelerated motion, acceleration from VT graph. This is important topic, how to calculate acceleration from velocity time graph, and how to calculate displacement from velocity time graph. So this all we discussed. So how to calculate acceleration from velocity time. So acceleration from velocity time means we have to find the slope of velocity time graph. So displacement can be we can find displacement from velocity time graph by finding the area under the curve. So kinematic equations for uniformly accelerated motion. V is equals to U plus AT. Those are all the equations. Now, let us try to continue our session. So today's contents, that what we are going to discuss in lesson 4 in motion in a straight line. We are going to derive the equations of motion in graphical method, motion under gravity, which is very important for IPE exams and competitive exams also, equations of motion for freely falling body and vertically projected bodies, the numericals based on equations of motion. Some examples we are going to see how the equations of motion are going to be applied. And another important topic, which is relative velocity. So these are the topics what we are going to cover in this session today. So dear children, so you know how to find the area, and we know what is VT graph. So the topic is area under VT curve for uniform acceleration. So how to find the area? So this already we discussed in the last class. Velocity time graph is given. So this is for uniform acceleration. This is the velocity time graph. And now, if I take shaded portion, which is under velocity time graph, that means this is a straight line. So this is a straight line, which is indication of the uniform accelerated motion. So the area under velocity time graph, or the area under velocity time curve, means this area and as well as this area. So that is the reason why here the shaded portion, one is rectangle and other one is a triangle. The total shaded portion under this curve, this is the curve, that actually the curve is a straight line here. So this straight line, this is the straight line, and the triangle and the rectangle are going to be the area under the curve. That is what the straight line. So what is the area under VT curve will? So this will give the displacement. So derivation of equations of motion from VT graph. So how can you derive? We are going to derive S is equals to ut plus half at squared from the graph. The most important question, many number of times came in the exam, public examination. So derive S is equals to ut plus half at square by using graphical analysis from velocity time graph. So this is the velocity time graph. You can see, children, this is the velocity time graph for uniform acceleration, because in this session we are dealing only uniform acceleration. We are not going to discuss non-uniform acceleration. So this is the velocity time graph. So you can understand this is origin, and on y-axis we have velocity. So at t is equal to 0, the velocity is initial velocity u, and this is the velocity after t seconds of time. So this is the time t seconds. So after t seconds the velocity is v. So now, so this distance on y-axis is u, and the total distance on y-axis is v, and this distance is v minus u. It is clearly indicated in the diagram. Now let us try to derive S is equal to ut plus half at square from this graph. As you know, displacement is area under velocity time graph. This already we know. So how to find the displacement means area under velocity time graph. So displacement S is equals to area under rectangle OACD. So this is the rectangle, you can see OACD. So this is the rectangle, and area of triangle ABC. So area of rectangle OACD plus area of triangle ABC. So S is equals to, you know, the area of a rectangle. Area of a rectangle is length into breadth. So length into breadth means, so this is OA into OD. OA is, this is OA, and this is OD, length into breadth, plus area of the triangle. So area of the triangle is half into base into height. So here you can see half into base. Base is AC. So here this is base. Here this is base AC and height BC. Right? So half into base into half into base into height. Now S is equals to ut plus half at square. So we are going to derive that S is equal to ut plus half at square. So S is equals to OA. It is very clear from the diagram that OA is equal to U and OD is equals to T. You can see in the diagram also, plus half into AC. AC means A to C, x-axis, the distance is time, and BC is V minus U. So that is UT plus half T into, from first equation of motion, you can write V minus U is equals to AT. So already we discussed V minus U is going to be equal to AT. So how V minus U is going to be equal to AT? So let us see once how it is going to be equal to AT. So you can see here, as you know, the equations of motion. So that is V is equals to U plus AT, right? So V is equals to U plus AT. From that you can write time is equals to V minus U. 1 minute. So V minus U is equals to AT. How we'll see how V is equals to U plus AT. This is equation of motion. So V minus U is equals to AT. So from this relation, you can substitute V minus U as AT in this equation. So then if you simplify, then you'll get S is equals to UT plus half AT square. So S is equals to UT plus half AT square. This is very, very important relation. So this is how we can derive S is equals to UT plus half AT square from the graph. So very important Question for IPE exam, derive S is equal to ut plus half at square from velocity time graph. So you can pause the video and you can go through the derivation once again while you are revising so that you can understand in a better way. So S is equal to ut plus half at square is the equation which is the relation between displacement and time. Coming to the derivation of equations of motion from VT graph, that is v square minus u square is equals to 2as. How we can derive the another equation v square minus u square is equals to 2as. So dear children, you can see this is in the form of a trapezium. The given figure, this is in the form of a trapezium. This is a trapezium. So if you want to find the area of trapezium, you know the formula for area of trapezium. So we are going to derive that concept here. So with the help of area of the trapezium, we are going to use the concept of area of trapezium here. So S is equals to displacement is equals to area of trapezium OABD. So S is equals to the formula for the area of trapezium is equals to half into the sum of the two parallel sides BD plus OA. You can see in the diagram. So BD is one side and this is BD, and OA is another side which has two parallel sides. So BD plus OA into AC. So AC is the distance, the perpendicular distance between the two parallel lines. So now S is equals to half into BD. BD is V. B to D distance is velocity, that is the velocity after t seconds of time, and plus OA is equals to already U into AC is equals to time. So everything is there in the diagram. So S is equals to so V plus U into V minus U by A. So here you can see, dear children, the simplification part. It is very important to simplify this one. So here this is half into V plus U into T. So again we are substituting T here. So actually we know that V is equals to U plus AT. So V minus U is equals to AT. So V minus U by A, from this equation, V minus U by A is equals to T. So V minus U by A is equals to T. So I am substituting the value of T as V minus U by A here. So T is equals to V minus U by A. So this is how we can substitute T as V minus U by A in this equation. So now if you see, then S is equals to half into, as you know, V plus U into V minus U, A plus B into A minus B, V plus U into V minus U is V square minus U square by A. So from this, we'll get V square minus U square is equals to 2AS. So this is how we can derive the equation V square minus U square is equals to 2AS from the graph. So this is also an important equation where you can use in the problems. In problem solving, these equations of motion are going to play a very important role. S is equal to ut plus half at square, and now v square minus u square is equals to 2as, right? So remember children, here u initial velocity, v velocity after s displacement, and a is uniform acceleration. Okay, you have to mention all these terms while you are deriving this. Next kinematic equations that what we discussed till now is v is equal to u plus at, s is equal to ut plus half at square, v square minus u square is equals to 2as. These are the equations of motion for uniformly accelerated motion, and as well as the initial displacement of the body is 0. That means the body is at the origin at t is equals to 0. If body has already displayed, that means in the beginning, that means at t is equal to 0, if the body has already have some displacement, then the equations of motion are, we are going to discuss those equations of motion in the coming class. Now let us see how we can apply the formula for the problems. So dear children, this is an important problem. A bullet moving with a speed of 150 meter per second strikes a tree and penetrates 3.5 centimeter before stopping. A bullet is moving with a speed of 150 meter per second. It's a very high speed. So bullet is going to move with 150 meter per second, strikes a tree and penetrates 3.5 centimeter before stopping. That means as it enters into the tree or a log, wooden log, it is going to stop after passing 3.5 centimeters because of the resistance offered by the tree. So what is the magnitude of its retardation in the tree? So as you know, retardation means acceleration and velocity are going to act in opposite direction. That is what negative acceleration. So how to find this one? So this is a tree or a wooden log and this is a bullet. See children, you can analyze the problem. We have a tree and as well as a bullet. So bullet is moving with 150 meter per second. You can see the bullet is moving till it reaches the wooden log. Its speed is 150 meter per second. And after reaching the wooden log, it is stopping after a distance of 3.5 centimeters. After traveling 3.5 centimeters distance, it is going to stop. Then which equation of motion we have to use? We have three equations. V is equal to u plus at and s is equal to ut plus half at square, and another equation v square minus u square is equals to 2as. So here we have to find acceleration and what are the given quantities. So what are the given quantities? We have velocity is given, initial velocity, final velocity is given, that is it is 0 because it is stopping, and displacement is given. So we have to select the relation which is having velocity and displacement, that is v square minus u square is equals to 2as. So we have to use this equation. So many number of students are going to get confused which equation we have to use for the given problem. So first you write the data. What are the given quantities? Velocities are given, displacement is given. See the relation. Which equation we have to use? So we can use v square minus u square is equals to 2as. So in this equation we have initial velocity as 150, final velocity as 0, acceleration we have to find, that is what retardation, and displacement is given as 3.5 centimeters. And another thing, this is very important, we have to convert the units. As you discussed in the first chapter, every unit is in SI system and all the units in the given problem should be in the same units. So for that you have to convert centimeters to meters. So as you know, velocity, final velocity is 0 because the bullet is going to stop inside the wooden log, minus u. U is initial velocity. Initial velocity of the bullet is 150. So 150 square is equals to 2a, that is acceleration. We have to find, don't substitute the sign for acceleration because you'll get the answer with negative sign. That negative sign itself indicates the retardation. And displacement is 3.5 centimeters. So 3.5 centimeters, if you convert it into meters, it is 0.035 meters. So if you simplify this, acceleration is minus 150 into 150 by 0.07 and acceleration is minus 2250000 by 7. It's a huge value because the tree is going to offer a very high resistance to the bullet so that the fast moving is going to stop. Imagine that if you are moving with very high velocity, if the person, if he want to stop you, he has to apply more force. That means he has to oppose you with a very high amount of force. That means the wooden log is going to restrict the bullet with very high force. That means very more magnitude of force. So acceleration is 321,400 meter per second square. That means 3,21,400 meter per second square. So you know how to mention a number in the standard form. So A is equals to minus 3.214 into 10 power 5 meter per second square. So we got negative sign. So the negative sign indicates that it is retardation. So this is how we can solve the problems based on equation of motion. This is an example where you can use the one particular equation of motion. Dear children, so I hope you understand this problem. We use v square minus u square is equals to 2as in this situation. Next, coming to equations of motion. At t is equal to 0, if the position coordinates are already s is equal to s naught, that means already if a body has some displacement in the beginning itself the body has covered some distance, then equations of motion are v is equal to u plus at, s is equals to s naught. For known equation, we know s is equal to ut plus half at square. We have to add the initial displacement to this equation, that's it. Because initially it has some displacement. So you add that displacement, and v square minus u square is equal to 2a into s minus s naught. Because initially it has covered some distance s naught, so total displacement will be s minus s naught. So these equations are for the displacement when already initially the body has covered some displacement. So these equations are also important when initial displacement is given. Initially, that means at t is equal to 0. If the position of the object is given, then you have to make use of these equations. So children, see v is equal to u plus at, because here no displacement is there in this equation. So this will remain as it is. But this equation consists displacement. So we have to add s naught to this one. Actually, s minus s naught we have to take. So minus s naught will become plus s naught here. So v square minus u square is equals to 2a into s minus s naught. So total displacement, the resultant displacement in this situation is s minus s naught. So instead of s, if you use s minus s naught, that will give the equations. Now, dear children, so this is a very famous picture. I think most of you can identify the significance and importance of this picture. So this is the Leaning Tower of Pisa. A famous mathematician as well as physicist conducted an experiment by dropping a heavy and a lighter objects from the top of Leaning Tower of Pisa, and he is none other than Galileo, and he concluded many things, how the gravity is going to play the role on the falling objects, and which object is going to reach the ground first, and in which situations the objects are going to reach first. That means if air resistance is considered, what happens? If air resistance is neglected, so what happens to the free fall of the bodies? Okay. So our next topic is motion under gravity. So very, very important topic for examination. So motion under gravity. So how the bodies are going to move under the gravitational force. And we are confined ourselves to a straight line motion, only one dimension motion. That means freely falling bodies, that means they have to fall down vertically down or vertically up. So our topic is motion under gravity, and it is a straight line motion. Strictly speaking, it is one dimension motion, whether falling freely from top to bottom, that is vertically downward direction or vertically upward direction. So freely falling bodies. So this is one of the case, motion under gravity. The one of the case is freely falling bodies. We'll see what is freely falling body actually. So dear children, you can see in this picture, the ball is freely falling. So it is dropped from the top of a building or a tower. It is falling freely. So we are going to discuss what is actually free fall detailedly. Now you can see this ball is also falling freely. So in these two examples, you can see the two balls are falling freely. So they are freely falling bodies. vertically projected bodies. Vertically projected bodies means in this diagram you can see a juggler is throwing the balls in upward direction from his hand. So the body is moving vertically up, and you can see another ball is thrown upwards. So another ball is thrown upwards. So this is also moving in vertically upward direction. So these are the examples for vertically projected bodies. So if you project a body vertically upwards, so this is how the bodies are going to move. Now, what is the quantity which is going to play an important role in the motion under gravity? So in case of motion under gravity, all the bodies are going to move under gravity and the bodies are going to be accelerated. Because if you see, if you drop a ball from a tall building, a 50-meter building or a 100-meter building, you can see the ball is going to speed up. That means the ball is accelerating. Gradually its speed increases. Is it right? Or otherwise, if you throw a ball from a building to upward direction, in the vertically upward direction, it is going to slow down. That means acceleration is acting down, so the body is going to get slowed down. So these are the examples for accelerated motion. So now we'll see what is acceleration due to gravity. Very important topic. So the acceleration gained by an object due to the gravitational force. So how acceleration is going to be gained? Earth is going to pull the object. So when it is pulling the object in its direction, in the direction of the force, the velocity increases. So velocity increases means it is going to speed up. So it is going to speed up. It is going to be accelerated. So acceleration is produced by the gravitational force. So the acceleration gained by an object due to the gravitational force is known as acceleration due to gravity. The magnitude of acceleration due to gravity is represented by g. The small g is the letter which is going to use for the representation of acceleration due to gravity. Acceleration due to gravity is always downward. In the previous example, we saw two examples. The balls are falling downwards. Okay. Even though if you throw the object in upward direction, the ball is eventually going to come down. That means acceleration due to gravity is always going to act in downward direction. This is very important. Acceleration due to gravity always acts in downward direction. And it is a vector quantity because it is always acting in downward direction because of the Earth's gravitational pull. So it is going to have a specific direction. So it is a vector quantity. And units, acceleration units, already you know acceleration units are meter per second square. So acceleration due to gravity is also meter per second square. So dimension formula is same as that of acceleration, m0 L1 t minus 2. So this is the information, the important point, key points about acceleration due to gravity. So these are very important points. Definition, representation, and in which direction it is going to act, and which type of quantity it is, whether it is a vector or a scalar. It is a vector quantity, and units and dimensions. Now coming to the discussion, the detailed discussion of a free fall. So very, very important discussion. So motion of an object under free fall. So how the motion is going to be described for a body when it is freely falling. So first we have to know what is actually a free fall. So what is actually a free fall? Free fall means if air resistance is neglected, the object is said to be in free fall. Whenever a body is coming in downward direction, if air resistance is neglected means the only force acting on the body is gravitational force. Other than gravitational force, no other force is going to act on that object. If only gravitational force is acting on the body or on the object, that means no other force is acting. Even though air is not going to apply any force on the body, then that is said to be a free fall. I hope you got the point. Free fall means air resistance is neglected. That's it. So throughout this chapter, we are going to neglect the air resistance. In this chapter, we are going to neglect the air resistance. That means we are not taking air resistance into consideration. Now, if the height through which the objects falls are very small compared to the radius of the Earth, the radius of Earth is very huge value, 6,400 kilometers. It's a huge value. But we are going to drop the bodies or the objects from 10 meters height, 20 meters height, or 30 meters height, like that. So the height that from which we are dropping is only in the order of meters, whereas the radius of Earth is 6,400 kilometers. So compared to the radius of the Earth, the heights from which we are dropping the objects is very small. So the acceleration is taken to be constant. That means even for free fall, we have to consider the acceleration to be uniform acceleration. Uniform acceleration means acceleration is constant throughout the journey. Acceleration is constant means velocity is going to increases equally in equal intervals of time. So every 1 second, the increase in velocity will be same. Free fall is uniform motion. So this is important point. Free fall is not non-uniform motion. This is uniform motion if air resistance is ignored. And magnitude of G. So experimentally, the value of acceleration due to gravity. So Newton found the value of acceleration due to gravity by conducting the experiment. The value comes out to be 9.8 meter per second square on the surface of the Earth. So on the surface of that, the acceleration due to gravity is 9.8 meter per second square. For the sake of problem solving, sometimes we will consider it as 10 meter per second square. We have to take G as 10 meter per second square only if it is given in the problem. Take G as 10 meter per second square. Then only we have to take G as 10 meter per second square. Otherwise, G is 9.8 meter per second square. Now coming to the important discussion. So how to take positive sign, negative sign for velocity, acceleration and all these things in solving the problems. So this is the important thing in student point of view, because most of the students will get confused how to apply the sign for velocity, acceleration and all these things. So this is very important. So how to apply the sign convention. Body falling freely. The freely falling body. Already we discussed what is a falling body, and now we'll see how we can apply signs for velocity and acceleration and all these things. Students, take the initial position of the body, that is to be at the origin. So initial position of the body, that means from where the body is falling, take that position to be origin. You have to take that position to be origin. So this is O. O is the origin from where we are dropping the body. And vertically downward direction is taken as positive. This is important. Vertically downward direction is taken as positive. So vertically downward direction is taken as positive. This is the sign convention that which we are considering here. So downward direction, you can see here in the diagram, the downward direction is considered to be positive. And as you know, acceleration due to gravity always acts downwards. Dear children, concentrate, this is very important. Acceleration due to gravity always acts downwards. So, and downward direction we considered it positive. So acceleration due to gravity is also positive. That is why A is equals to plus G. Once again, the initial position of the body is origin. O is the origin. Vertically downward direction is taken as positive. So vertically downward direction is positive. This is positive. So acceleration due to gravity always acts in positive direction. So A is equals to plus G. Acceleration due to gravity is positive because acceleration due to gravity always acts in downward direction. Downward direction is positive here. And coming to sign convention for a vertically projected body. So how can you consider while solving the problems related to vertically projected bodies? Again, the initial position of the body is taken to be origin. We have to take the initial position. That means where you are throwing the body, from where you are throwing the body, that is to be origin. So this is the point which is considered to be origin from where we are projecting the body vertically upwards. O is the position initially. And vertically upward direction is taken as positive. In this case, you take vertically upward direction as positive. So vertically upward direction positive. You can see upward direction is positive here. As you know, acceleration due to gravity, whatever the case, whether the body is moving upwards or whether the body is coming down, the acceleration due to gravity always acts downward direction. That you know, acceleration due to gravity always acts downward direction. But upward direction is considered positive in this case. So upward direction is positive. So downward direction is going to be negative. In straight line motion, already you know, only two directions we have. That is positive x, positive y, negative x, negative y. So if one direction is positive, that is upward, the downward direction is negative. So A is equals to minus G. A is equals to minus G. Only the sign of acceleration due to gravity is negative. Students, remember one point here. Minus G means the acceleration due to gravity is not decreasing. Many number of students are going to get confused here. Minus means it is decreasing. That's not decreasing sign. Doesn't it? Is it right? Does it mean that minus sign indicate decrease in acceleration due to gravity? No. Minus sign indicates that acceleration due to gravity is acting downward and vertically upward direction is positive. That's why the sign of A is minus G. Right? And you can see the detailed description of motion of a body falling freely under gravity. So how to discuss or how to describe the motion of a body and equations of motion. We have three equations of motion. V is equals to U plus AT, already very familiar for you. For the last three classes, we are discussing the equations of motion. V is equal to U plus AT, S is equal to UT plus half AT square, and V square minus U square is equal to 2AS. How these equations of motion we can write for a freely falling body. So that is the topic now. So you can see, children, here the body is falling freely from this point. The important point is, for a freely falling body, initial velocity is 0 because initially it is falling from rest. So initially it is falling from rest. So initial velocity is 0. The height from which it is falling is h. You consider that from h height it is falling. So downward direction. The initial point of the body is here and the final point of the body is here. So downward direction. So downward direction is positive. So S is equal to plus h. And acceleration due to gravity always act downwards. A is equal to plus G, as we discussed earlier. Now, let the body acquire velocity V after falling through a height h. So after falling through height h, if it acquires a velocity V, then we will see how the equations of motion we can write. So this is very important topic for the numericals, especially in solving numericals. So these equations will play an important role. First, as you know, V is equal to U plus AT for uniformly accelerated motion. Freely falling body, U is equal to 0. It is indicated in the diagram. You can see in the diagram also, U is equal to 0 and A is equal to plus G. So V is equals to GT. So this is the equation. For a freely falling body, V is equals to GT. That means after t seconds of time, velocity is equals to G into T. That means what you can conclude? With time, velocity increases. Very important point. With time, velocity increases. Every 1 second, velocity increases by 9.8. After 1 second, velocity will be 9.8. After 2 seconds, again 9.8 plus 9.8, 19.6. Like that, for every 1 second, the velocity increases by an amount of 9.8 meter per second. So that's why acceleration due to gravity is 9.8 meter per second square. Second equation, S is equal to UT plus half AT square. S is equals to H. that already we consider displacement is h and positive. Initial velocity 0, 0 into time 0, half gt square, a is equal to plus g. So from this, t is equal to square root of 2h by g. If you simplify this equation, you will get t is equal to square root of, if you simplify this one, you will get t is equal to square root of 2h by g, which is also known as time of descent. It is coming down. So how much time it will take to descend? So time of descent, root of 2h by g. Now third, v square minus u square is equal to 2as. V square minus u is 0. So v square is equal to 2g and s is h. So v is equal to square root of 2gh. From this equation, you can write v is equal to square root of 2gh. So the equations which are in boxes, very, very important equations. They are the equations of motion for a freely falling body under gravity. An important point is air resistance is neglected. If air resistance is neglected, so these are the three equations of motion for a freely falling body. Dear children, you can see once v is equal to gt, t is equal to root of 2h by g, v is equal to square root of 2gh. These three formula are very important for MSET examination and for all competitive examinations for one dimension motion. Now coming to the motion of a vertically projected body, how equations of motion we can write, how we can write equations of motion. So dear students, you can see O is the object from where we are throwing the object in upward direction. You can see in the diagram, a juggler is throwing the balls in upward direction. So this is the example vertically projected body. So this is thrown upwards. As you know the sign conventions clearly. Earlier also we discussed. So initial velocity is u. Initial velocity means with how much velocity we are throwing the object in the upward direction. And after t seconds of time, what is the maximum height reached by the object? So how much height the object is going to reach? And at that point, velocity is 0. Momentarily, the ball is going to stop. If you throw an object upward in upward direction, the body is going to stop for a moment and then again it will come down. So now let us see what are the equations of motion for vertically projected bodies. As you know, V is equal to U plus AT, the basic equation. At maximum height, V is equal to 0. As you know, maximum height means up to which it can travel. There momentarily it will come to rest. So there the velocity is 0 after t seconds. U and acceleration is minus g. You can see according to the sign what we considered here, vertically upward body, vertically projected upward body, A is equal to minus g. So if you substitute A is equal to minus g here, so you'll get t is equal to u by g. So time taken to reach that maximum height. So how much time the body will take to reach the maximum height? The juggler is throwing. So how much time the ball will take to reach the maximum height? That means to stop. That is time of ascent. T is equals to u by g. Now coming to second equation. As you know here S is equals to h and ut minus half at square. Right? Body is moving upwards. So the body is moving upwards and upward direction is positive. So h is equal to positive. So ut downward direction is negative here. A is equal to minus g. So minus half at square. And v square minus u square is equals to 2as. And v is 0. Minus u square is equals to 2 into a is minus g. You can see in the diagram why a is minus g and s is h. So h is equal to u square by 2g. So this formula is very important to find the maximum height. So while solving the problems, you can directly use the maximum height reached by a vertically projected body is u square by 2g. The maximum height reached by a vertically projected body is u square by 2g. You can see it in the box. So time of descent, sorry, time of ascent is u by g and maximum height reached is u square by 2g. So these are very important equations of motion for a vertically projected body. Now we'll see numerical based on the equations of motion for freely falling and vertically projected bodies. So this is a important problem, and this problem, this is also given many number of times in the board exams for 4 marks question. So dear children, you can see a multi-story building here. The height of the building is 25 meter and a ball is there on the top of the building. Now, if you throw the ball from the top of that building in upward direction, if you throw the ball from the top of the building in upward direction, then how much height that the ball is going to reach before going to stop? So we have to find, so how much height that the ball is going to travel before going to stop. That means in reaching maximum height, how much distance the ball is going to travel. See the children, a ball is thrown vertically upward with velocity 20 meter per second. The ball is thrown with 20 meter per second from top of the building. The height of the point from where the ball is thrown is 25 meter. That is there in the diagram. You can see how high will the ball rise. Up to what height the ball is going to rise. And how long will it be before the ball hits the ground. Very, very important problem. So we'll see, we are going to solve the problem by using equations of motion. Here children, you can see initially the ball is thrown with a velocity of 20 meter per second. Stepwise you can see, and which equation you have to apply? V square minus u square is equals to 2as. Final velocity is 0 because in upward direction the ball is going to move and momentarily it will come to rest in reaching a particular height, that is where the velocity is 0, and u is u, a is minus g because the body is thrown upwards, and s is h. So up how much maximum height it will reach from the top of the building, that is important. This h is from the top of the building, not from the ground. This h is from the top of the building because the point where we are throwing is the origin. That means our origin is the top of the building. So from the top of the building, this is the height h. So if you simplify by using, already I told h is equal to u square by 2g, you will get from this equation also. U square means 20 square, 400 by 2 into g. G is 10 because here it is given in the problem. Take g as 10 meter per second square. So if you substitute 400 by 20, that is 20 meters. So the height that the ball is going to reach from the top of the building is 20 meter. Now you want to find the time. How much time it will take to reach the ground from the top of the tower to reach the ground. Now use S is equal to ut plus half at square. S is minus h. Dear students, this is very, very important. Why S is equal to minus h? Because we are throwing the body from the top of the building. We are throwing from the top of the building and the body is reaching the ground. So initial point is the top of the building. Final point is bottom of the building. So the body traveled in downward direction. So the body is traveled in downward direction. So downward direction is negative because body is moving upwards initially. So initially body is moving in upward direction. So downward direction is negative. So S is minus h. If you substitute u as positive because the body is moving in upward direction, and a is minus g. If you substitute, already you know h is 25, u is 20, and g is 10. That is given in the problem. So students, I am giving a work for you. This is a quadratic equation. Already you are familiar to solve the quadratic equations. So from this we can find time. And students, for the quadratic equations you will get two values for the given time. Okay, and you can find an interesting thing after finding time from this equation. So think about that. What is the interesting thing after solving for time? Okay, the interesting thing is one value will get positive, one is negative. Okay, this is the work that I am giving for you. So you can get how much time the ball will take to reach the ground. Now, another important topic and interesting topic. that is relative velocity. So already the term relative is familiar for us. So relative means comparison. So the simple term to understand the concept of relative is difference. Relative can be applicable for non-living things, for living things, for scalars and vectors. For anything we can apply the concept of relative. Suppose if you take you and your brother, okay, your brother is taller and you are shorter than your brother. That means your height is relatively smaller than your brother's height. Okay, and your brother's height is relatively more than your height. So you can compare. Relative is the difference. Okay, and as you know, rest and motion are relative. Dear students, remember relative means difference. As far as the one dimension motion, straight line motion is concerned, the better way to understand the concept of relative is how much difference is there. How much difference is there in the positions, or how much difference is there in the velocity. That difference is relative, right? So relative motion, rest and motion are relative. Given object may be at rest, it already we discussed, with respect to a particular observer, but it may be in motion with respect to another observer. One object may be at rest and it may be in motion with two different frame of references. So same object, it can be at motion and it can be at rest. So velocity is rate of which motion takes place. So if the body moves, then only velocity is going to acquired by the body. So if position and motion are relative, then velocity is also going to be obviously relative. So velocity is rate at which motion takes place is also known as a relative. So now we'll see. Dear students, you can see here two cars are there. One is car A, the other one is car B. So this is car A and this is car B. So velocity of car A is VA and velocity of car B is VB. Let us consider VA and VB are the velocities of these two cars. That means car A and car B are moving with velocities. Car A is moving with some velocity and car B is moving with some velocity. So what is relative velocity? So relative velocity of A, that means car A, with respect to B. Dear children, with respect to B, with respect to B means if B is observing, with respect to means what? When B is observing, what is the velocity of A? Suppose if you are traveling in a train and on a parallel track another train is there. So two trains are traveling on a parallel track. If two trains are moving, if two trains are moving with same velocity, you can't identify whether the bodies are moving. You are supposed to be at rest. That means you think that you are at rest. So this you might have observed in many number of cases in your day-to-day life while you are traveling in bus also. Some buses are going to overtake you. So we have to calculate. The convenient way to calculate is relative velocity in two body problems. So relative velocity of A with respect to B, with respect to means with B. So VAB. So VAB is equals to, VAB means velocity of A. Yes, students, listen carefully. Velocity of A with respect to B. VAB means velocity of A with respect to B is equals to velocity of A with respect to B means what? Relative. Relative means difference. Already I told clearly, relative means difference. So difference is VA minus VB. Now relative velocity of B with respect to A. That means B is traveling, A is traveling, and if A is observing B, what happens if observer is A and he is observing the car B? That means relative velocity of B with respect to A. That means in A point of view, with how much velocity B is moving. That is VB minus VA. Velocity of B with respect to A is VB minus VA. I hope you understand the formula. Now coming to see how to calculate the relative velocity. Mathematically, how to calculate the relative velocity or how to formulate the relative velocity. If the two cars are moving in the same direction, if the two cars are moving in the same direction, you can see first car is moving towards right and second car is also moving towards right. If two cars are moving in the same direction, let us say velocity of A is 20. Let us consider it is 20 plus means it is moving in rightward direction. That's why it is plus 20. Velocity of B is also rightward, so plus 10. So these are the two velocities. Now velocity of A with respect to B, as you know, VAB is equals to VA minus VB. Dear children, you can see VAB, velocity of A with respect to B, is VA minus VB. That means substitute the values. 20 minus 10, 10 meter per second. That is positive. Positive value and 10 meter per second. That means relative velocity of A with respect to B is positive. That means relative velocity is also in rightward direction. That means, simply speaking, the difference in the velocities of the two bodies is 10. Okay. So relative velocity of B with respect to A. That means if relative velocity of B with respect to A, if A observes, then it is minus 10. That means the relative velocity of B with respect to A is minus 10 meter per second. That means for A, B appears to be moving towards left. This is quite interesting. For A, B appears to be moving in leftward direction. This you can observe while you are traveling in a bus. The trees appears to be moving backward direction. Are they really moving backward? No, they appears to be moving in backward direction. So backward direction means negative as far as the bus is concerned. So similarly, here negative sign means for A, the body B appears to be moving in opposite direction. Now, if you see another case, if the two cars are moving in opposite direction, if one car is moving in this direction and another car is moving in opposite direction, if the two cars are moving in opposite direction, then how to calculate the relative velocity? So if they are moving in opposite direction, velocity of A is plus 20, velocity of B is minus 10, because B is moving in leftward direction, towards left. So relative velocity of A with respect to B is same VA minus VB, that is plus 30 meter per second. You try to understand what is the importance of plus sign here. And velocity of B with respect to A is minus 30 meter per second. So the quite interesting thing is relative velocity of A with respect to B and B with respect to A are exactly opposite. One is plus 30 and the other one is minus 30. That means the directions are opposite. Now coming to recap what we learned in today's class. Derivations of equations of motion in graphical method. How the bodies are going to move under the influence of gravity. Equations of motion for freely falling and vertically projected bodies. Numericals based on equations of motion and relative velocity. So let us try to solve these questions. Can the equations of motion be used when the acceleration varies with time? If acceleration varies, can we apply the equations of motion? That is the question. Can the velocity of an object be in a direction other than the direction of acceleration of the object? If so, give an example. Give an example where the velocity of an object is 0, but its acceleration is not 0. A ball is dropped from the roof of a tall building and simultaneously another ball is thrown horizontally with some velocity from the roof. Which ball lands first? And explain. So these questions are very important questions for the board exams. You try to answer these questions, right? And these are the attributions. And thank you, children. So we'll meet with another session in the coming classes. Thank you, madam.
Thank you, sir. It was a wonderful presentation. I think with today's session, we'll end this chapter, motion on a straight line.
Yes, yes.
And children, the equations of motion of kinematics describe the most fundamental concepts of motion of an object. It's very important. And the numericals, the concepts are the foundational facts for competitive exams as well. and they can easily be used to calculate expressions such as the position, velocity, acceleration of an object at various times, and all the practice all the equations of motion, their derivations and all. And sir, thank you very much. You have clearly explained the numericals on these concepts also. Thank you, sir. And we'll start another interesting chapter in the coming session. Thank you, sir. Thank you very
Okay,
much.
madam. Thank you, madam. Thank you.
Thank you, sir.